Okay, Assalamualaikum class. Welcome back to EECE 1316 since you just done your midterm. So this is the continuation of the AC circuits. That is AC power analysis. So what you are going to cover here is about the AC power, where the name is instantaneous power, average power, apparent power, and also the complex power. So for this chapter, we are still in learning outcome number 2. You need to know how to perform the phasor analysis. In the previous chapter, you learned on how to analyze the AC circuit by change to phasor. You learned the impedance combination and to change the inductor and the capacitor in terms of the impedance. So now we would like to see how you're going to calculate the power of the AC circuits. So these are the important terms. The first one is the instantaneous, average power, effective value, power factor, apparent power, and complex power. Okay, for the first one, we call instantaneous power. So in your previous chapter in the DC analysis, how you calculate the power is P equal IV, or P equal V squared over R, or I squared over R. So this formula apply for DC analysis. Now, how about AC analysis? So in AC analysis, your source here is in terms of AC circuits, right? And also your current is also will change by time. So how you calculate the power also will change by time. P equal IV, so IT multiplied by VT. So this is what you got here. PT is equal to VT multiplied by IT. So you know that your VT is equal to Vm cosine omega t plus delta V. And your IT is equal to peak amplitude cosine omega t plus theta I. So how you calculate the power, instantaneous power, you just multiply together. So the constant here, you are taking the constant together to become Vm multiplied by Im, and the cosine and cosine you multiply together. Using the trigo identity, when cosine A multiplied by cosine B, you have the half. This is what we got, the half here. Cosine A minus B. So in here we have what is the constant? Vm and Im. So you need to put both at one part and another part. So these are the constant with the half, right? And then you need to A minus B means this is A. The whole here is A. The whole here is B. So we minus, it become Wt minus Wt become 0, become delta V minus delta I. And then you A plus B, Wt plus Wt become 2Wt plus delta V plus delta I. Okay. So once you got this formula, what does this means? So from this formula, okay, so the in front one here, from here until here, we call this one a constant power or average power. This is the real power from the AC circuits, where this is in watt. Okay, the other one is, since it involves the omega here is the angular frequency. So it changed by time, right? So we call this one sinusoid power. So what we're going to focus on is what we call the average power here. So half, we call here P equal half Vm Im cosine theta V minus theta I. So this is what we call average power that is calculated in watt. So if your P value is more than 0, it is absorbed. If P less than 0, it is supply. So usually the resistor will be absorb power. The source will supply the power will be negative. Okay, now from this equation, you know that the in front one here is the average power, right? So this average power denoted by P, the unit is watt. So what is actually average power? So if you see the formula here, it's the same as what you got just now. The in front one, the constant half Vm Im cosine theta V over theta I. So it's the same, right? So actually how you can get this one? Average power is the average of the instantaneous power over one period. So this is what we call over one period. You're going to integrate your PT, the instantaneous power, from 0 to t. So this one you can learn on the derivation, but I will not show here. So the final answer will be half Vm Im cosine theta V minus theta I. So this is what we call average power that will measure in watt. Okay, so if we see from this formula, there is no time dependent here. It is a constant. So this average power is not time dependent. And we have here cosine theta V minus theta I. So we are going to check whether this is either leading or lagging, right? So if your theta V is equal to theta I, means there is no phase shift. So this one is purely resistive. If the shift here between theta V and theta I is plus minus 90, so it is called reactive. So reactive here comes from where? The impedance where we have the capacitor and also the inductor, means it have a leading and lagging inside. If P is equal to 0, means the circuit absorb no average power. Okay, so that's all about average power. So as the summary, just now, what is the instantaneous power? Is your Vt multiplied by It. And what is your average power? It is a constant. So the formula is half Vm Im cosine theta V minus theta I. This is what we call average power. You measure in watt. How you can get this one? You're going to integrate this by time, by period. Okay. So the one that we learned just now is VMIM. So what is VMIM? Is the peak value. This is a sinusoid, right? So this is the peak value, either up or down. If it is IM, so here is the peak value. So now I'm going to introduce you another terms called effective value, or what we call here root mean square. So it can be either current RMS, or we call here RMS, or voltage RMS. So what is actually this effective or RMS value? So from the definition here, effective value, let's say we call this one IRMS. What is IRMS? Is actually the effective value of the predict current. Why predict? So this is actually comes from the AC, right? Predict current is the DC current that deliver the same average power to R as a predict current. So what does this mean? So in your AC, we have another term what we call IRMS. So what is this IRMS? Is actually the effective value, or we call this one DC value effective. It measure in DC value of the AC circuit. From this IRMS, it will deliver the same power, almost the same power as the predict current. Okay. So you can consider you have AC, but how you can calculate the DC value of the AC? We call RMS, root mean square. So what is the relation between IM and the IRMS? So this is the relation. I root mean square, the effective value of the current is equal the peak current. Where is the peak? So let's say this is the peak. Divide by square root if it is a voltage RMS is equal the voltage peak. Where is the voltage peak? Let's say I draw here a peak, divide by square root 2. So this is the there is some derivation, but I'm not sure again here. We just jump to the formula. So what can you understand from this RMS? It's actually the effective DC value of an AC circuit. Okay, that's why you need to divide by square root 2. So please take note that when we're talking about effective value, it is actually the RMS value. So they are the same. Okay, so now in the previous slide, you learned about the average power, right? So how you're going to change this formula to become RMS? So let's define here. Your IRMS just now is equal IM over square root 2. Your VRMS is equal VM over square root 2. So you know the average power just now is half VM IM cosine theta V minus theta I. So how you're going to change this one to become RMS? So you just change, you know here IM is equal IRMS multiplied by square root 2. Same here, VM equal VRMS multiplied by square root 2. So what is VM? VRMS square root 2 multiplied by what is IM? IRMS square root 2 cosine theta V minus theta I. So square root 2 multiplied by square root 2 is equal to 2, right? So because you're going to cancel the square root, so this one become 2, and then 2 divided by 2 here, you are going to cancel out. So you become VRMS, this one, and this one will be cancelled out. IRMS cosine theta V minus theta I. So this is the formula for average power, where you're going to measure in watt. So let's go back to this here. So this is what I derived just now. How you calculate the average power in RMS? P is equal VRMS IRMS cosine theta V minus theta I, if you use RMS. But if you use the peak value, you need to have a half VMIM cosine theta V minus theta I. So when you calculate later, if you use RMS, both need to be in RMS. If you choose to use VM and IM, both need to be in IM. So they need to be in the same phase, same unit. You can't mix one VM, one IRMS when you want to calculate the power. Okay, so let me summarize. So first, you learn about instantaneous. That is called PT is equal VT multiplied by IT. Second, you learn about the average power. That is what we call P, measure in watt. What is average power? This one, half VMIM cosine theta V minus theta I. And the third one, how you measure your average power in terms of RMS. VRMS multiplied by IRMS cosine theta V minus theta I. So this is the first formula. Second formula, where you're going to divide by 2. Number 1 is VM. Number 2 is RMS. What is RMS? RMS is the root mean square, where it's actually the effective value of an AC circuit. Means like you're going to let's measure it in DC. So you know this is in AC, right? So square root 2 means here. So this is what we call RMS value, where the relation is IRMS equal the peak value divided by square root 2. Okay, so that's all for this video. Assalamualaikum.